Hello everybody, welcome to another Hinstitute Physics Friday here at the Hinstitute. So I have a wonderful little tie that one of my students got me that talks about falling objects. So it says, it's not the VF equal VI plus AT that kills you, it's the F equal M delta V over delta T, and then splat. And the idea of that is it's not the fact that you're moving really fast, it's actually the force and the change in momentum right at the end that's actually going to do it. So fun little tie that I was wearing today. I thought I'd give a shout out on the Hinstitute. So today I created kind of a fun little contraption that I thought I would kind of share with you. So I've got it sitting on the desk back here. So I'm going to set this down and then kind of show what I've got. So what I've done is I've taken a meter stick and I've attached a plastic cup. So this is just an empty plastic cup right here. And then at this end, I took a little ring, a plastic ring, and I've got a little bouncy ball that's sitting in there. So the idea is I'm going to have this sitting on my desk and I'm going to lift it up and I'm going to let it fall. Okay, so I'm just going to let it fall. Now, we know that everything should fall with the same acceleration. So if I have it fall with the same acceleration, we should get something interesting happen. But one of the things I want you to kind of notice is the ball is right here on the end, the cup is over here. I want you to watch what happens afterwards. So ready? 3, 2, 1, go. That was trial number 1. Let's try it again. Works pretty good, but it hasn't been working every single time. Bam! Notice that the ball actually fell in the cup. But how does that work? How does it actually fall in the cup if it's falling at the same rate? So the idea is when I have this sitting up here like this, the ball actually falls straight down, so it's falling straight down, but the cup moves from being over here to being here, so it ends up right underneath it. Now that only works because the center of mass of my meter stick is what's actually accelerating. So the point way over here, in other words, the meter stick that's actually falling, it's rotating around this axis, is actually accelerating at a greater rate than the acceleration of gravity because the center of mass of the meter stick is accelerating at the acceleration of gravity, but a point farther away is actually going to have a greater acceleration since everything's rotating around this end. So the neat thing is, as this ball starts up here, when this falls, it falls down, lands right in the cup.